But today we're going to do the properties of logarithms. So I really need everybody paying attention. I promise we're going to get you to the board and let you do some review work, but first we've got to learn our properties, or at least get started learning our properties. Okay? Okay, so let's get our note sheets out.
I just want to be like just be able to flip it down and touch it right here.
Will, who's missing on the archer table?
Have you ever done it?
Is that it?
Yeah.
One hair.
I have done it and I feel like my heart would have a hard time. I'm not
Okay, so we have our note sheets out. Here we go. The first problem says, is everybody looking? Hey, stop. No more talking. We've got to get this down, and then we'll get you to the board and let you practice. We're on the back of number 26. We're on the back of page 26. The very, very bottom, it says write as a single logarithm. Now, I do not know how much of this you remember. Some of you seem to remember a lot about your logarithms, and that's awesome. Does anybody remember how to take these two logarithms and squish them together into one? Does anybody remember how to do that? No. When the logarithms are subtracted, it means the numbers were divided. When the logarithms are subtracted, it means the numbers were divided. So if we have the log of x minus the log of y, we're going to put that together into the log of x over y. Now, groupies, that's a property. You need to know that. Put a star by that. It's important. We're going to do lots of problems where you're going to have to make that connection. That if you have a log minus a log, you're going to want to put it together and make it one logarithm. Only it won't be a minus problem anymore, it will be a division. Now, look at problem B. When I wrote this sheet, I wasn't messing around. This has got a challenge in it. Two things to know in this problem. Everybody's paying close attention.
Excuse me, Russian. Can I please have Catherine Baumgartner report to the front office?
Yep.
Thank you.
Gibran, you're going nowhere. I'm going to strap you down. Okay. When there is a number out in front of the logarithm, Abby Brady, when there is a number out in front of a logarithm, that number becomes an exponent. So this is going to be written as the log of x squared plus the log of y. Whenever you see a coefficient on a logarithm, Bryce Acreage, whenever you see a coefficient on a logarithm, it means an exponent. So 2 log x becomes log x squared. Now, I have 2 logarithms being added together. Now, take a wild guess. Remember when they were subtracted? I put them together as a division. These are being added. I'm going to put them together, but I'm going to put them together as a multiplication. Exactly. When logarithms are added, the numbers themselves are multiplied. Let's look at C. Oops. Now, do you remember what I just told you? In fact, I said it 3 times once to Bryce because he wasn't paying attention. When there is a number, a coefficient, out in front of a logarithm. See how you got this 1/3 out here? What do you do with that 1/3? It becomes an exponent. So this guy's going to go right here. So I'm going to have the log of z to the 1/3 plus the log of w. Now, I see a logarithm plus a logarithm. Do you?
I do, well, it doesn't.
Those are going to get squished together. We always want to put them together. So instead of having a log plus a log, I'm going to put it together as one logarithm, and what's going to go in that parentheses?
Z 1/3 plus W.
Not plus, times W, times W. Remember, when the numbers, or excuse me, when the logarithms are added, when the logs are added, the numbers themselves are multiplied. Maya?
Would it be wrong if you said Z for like the square root of
Cube root of C? No, that would be absolutely fine. So Maya's question is, could I have written this like this? And the answer is absolutely. Okay, you guys, these are kind of challenging problems. Let's see if we can work our way through them. When you look at this, this is problem D. When you look at problem D, Suzanne, you started that, then Abby got involved, then Kaylin got involved.
What did I do?
I don't know.
was
I want
looking
your
at my
beady eyes
paper.
looking this way.
Okay, I was looking at my paper though.
See this number out here in front of this logarithm? What does that number mean? It's an exponent. So he's going up here, and I'm going to have the log of xy to the 4th. Now what about this 3 right here? Maya Brownlow. See that 3? He's in front of a logarithm. What am I going to do with him? What did I do with this number in front of that one, Maya? What?
Make it an exponent.
Make it an exponent. So this is going to become the log of x cubed. If there is a coefficient in front of the logarithm, make it an exponent first. Right off the bat, step 1, get rid of it, make it an exponent. Now, I did that twice, here and here. Now I have, Thomas Berg, a log minus a log. I'm going to put that together into one logarithm. What's going to be inside this parentheses, Thomas? Now it's a log minus a log.
So it'd be, when you bring the x and the y down?
No, when I take it, when I have a logarithm minus a logarithm, look at our very first example. Look at number 1, or A. What did I do with that? No, on the other side. Down at the bottom. What did I do? That was a minus problem.
The x over y.
It became a division. So this is going to become x to the 4th, y to the 4th, over x cubed. This over this. This over this. Because when you have a log minus a log, it means you're going to do a division problem. And I'm dividing the first one by the second one. Now, does this confuse anybody, how I went from this to this? Does everybody understand that xy to the 4th is x to the 4th, y to the 4th? Bless you. Now, if we want full credit on this problem, though, we're not done. What do you notice here?
Simplify.
You can simplify. And what would that simplify into? What would be left on the top?
X to the first one.
X, y to the 4th. And I don't have anything left on the bottom, do I? So this would be the final answer to the problem. These are tough. E is a lot easier. E says we have the log of 4 plus the log of 7. You're going to write that as one logarithm. This is a log plus a log.
Okay, I think.
What
I
does
know.
that tell me about the numbers themselves?
They get smushed.
They get multiplied, multiplied, multiplied. When the logarithms are added, the numbers are
So 28.
multiplied. So 28 is the answer. Yeah, or log 28. Log 28.
So with subtraction, they get divided.
Okay, so we've got two logarithms here, and as Gibran has pointed out, they're being subtracted. When logarithms are subtracted, when we squish them together, it becomes what? What kind of problem? Add, subtract, multiply, or divide?
Division.
It becomes division. So this is going to become 16 over 8, which reduces to log 2. 2 points I'm trying to impress upon you. One is, if there's a number in front of a logarithm, I want you to make it an exponent. The second one is, if you have two logarithms, I want you to put them together. If they're being added, you put it together as a times. If they're being subtracted, you put them together as a divide. How about G? We're going to put this together as one logarithm. Now remember, ln is just a symbol for log base c. It's a logarithm. So I'm going to put this together as one logarithm. 19 over 8. Very good, Ethan Topham. 19 eighths. And I'd just leave it 19 eighths. All right. Looks very scary, but you can handle it. How do I start?
Okay, let me get this straight.
What?
Move the front number to the.
Yep, move the front number to an exponent. Very good, Tyler. Move both of them. So I'm going to have ln 2 cubed plus ln 36 to the 1/2. Now we got to simplify this. What's 2 cubed? 8. 8. So that's ln 8. Here's the tricky one. What's 36 to the 1/2 mean? 6. The square root of 36. Very, very good. Super-de duper. How did we know 36 to the 1/2? That's the square root of 36, right? That's how we got 6. What's the final answer to the problem?
48.
ln 48. Not 48, ln 48. You're taking the two logarithms and squishing them together into one logarithm. Awesome. Now, look at the next set of problems. These are the opposite. These are in one logarithm already, and you're going to pull them apart into 2 or more. Okay? So think about that for a second. Now we got to put everything in reverse and think backwards. If we have ln xy, and I tell you to pull that apart into 2 logarithms, what are you going to do to the 2 logarithms? Add, subtract, multiply, or divide, since this is a times problem. You'll add. So it will be ln x plus ln y. Let me say it again. When numbers are multiplied, their logarithms are added. When the logarithms are added, the numbers are multiplied. Now look at the next one. It's a division problem. Anybody know how that's going to break apart? Now we're breaking it apart. Anybody know how that's going to work? What'd you say, Katie Roth? B is a log.
Yeah.
Yeah, so it's log.
Log x minus log y.
Yep, that's exactly right. Log x minus log y. These are both properties that you need to know. Okay. Patrick, you paying attention?
Actually, right now, I guess I'm there.
This is a division problem, isn't it? Olivia Willis?
It is 3 log x minus 4 log y.
Okay, she is all over this. She's exactly right, but she did kind of 2 steps in one. So let me put that middle step in there, just in case you're confused. If you can go straight from here to here, you are awesome, but there is a middle step. And that middle step would be log x cubed minus log y to the 4th. How do I know that? I know that when I have a division problem, when I break it apart, it becomes a subtraction. Suzanne? When I have a division problem, when I break it apart, it becomes a subtraction. So this would be my first step, right? Yeah. And then an exponent is the same as a coefficient in logarithm land. So if my job is to break this all the way down, I'm going to take that 3 and put it out here in front. I'm going to take this 4 and put it out here in front. Okay, we're almost done. Any idea about this one? Okay, what, somebody said a fractional exponent? What does a 5th root mean?
You gotta pick what goes, what
A
times 5?
5th root means what exponent? Not 5. 1/5. Fractional exponents are radicals. So when you see a radical, you immediately think, oh, fractional exponent. The 5th root is the 1/5 power. Now tell me what I'm going to do with that 1/5. Where's he going to go?
In front.
He's going to go in front. Exponents become coefficients and vice versa, you guys.
Wait, is that the answer?
No.
Okay.
There's one more step. We have to break it apart now. That's a multiplication. So we're going to break that apart as what? Add, subtract, multiply, divide.
Wait, no, I lied. You add.
That's the final answer.
But wait.
Okay, I am a little distraught that I hear so much side chatter. This is hard stuff, and we really need to pay attention. Run, you should have your note sheets out. Okay, let's look at E. We only have 4 more to go. Let's look at E.
X to the 1/4.
Okay, very good. So a starting step would be to write that as x to the 1/4 over z. Would everybody agree with that? Now, let me show you a common mistake at this point. Sometimes kids will say, ooh, an exponent. I'm going to pull it off and write it out here in front. Can anybody tell me what's wrong with that? Sometimes that's okay. It was okay in this problem. That's what I wanted you to do. But what's wrong with it here? Why won't that work? Katie?
It would have the exponents x and z.
Exactly. This exponent only goes with the x. So before I can pull it off, I have to separate my problem. So my next step is the log of x to the 1/4 minus the log of z. Now, why did I break it apart as a minus problem? Because it's a division. And divisions break apart as subtractions. And subtractions go together as divisions. Now that I have it separated, can I pull the 1/4 off now? Yeah, because it only goes with the x. Very good, Katie Thomas. Now let's look at f. Let's start it the same way. Let's deal with that radical. What will I do with that radical? I'll write it as a 1/5 exponent. Now, a minute ago, I said, don't pull the exponent off. But can I pull it off this time? Why can I pull it off this time?
It goes with both.
Because it goes with the whole thing, right? It goes with both. So I can go ahead and pull it off. Now, you still have to split your problem apart, though. When I split it apart, I'm going to have what? The log of x minus the log of y. Remember, the logarithm of a division becomes a subtraction. Yeah. You don't get what?
The difference between this one and the one before.
This one and this one?
Yeah, like why can you move the exponent?
Because here, the exponent only goes with a piece of the problem, and here, the exponent goes with the whole problem.
Yeah, but the written. Just kidding. I got you.
See the difference? Okay. It is confusing, for sure. Okay, let's look at this one now. Do you see an exponent?
Yeah.
Do you want to pull that right out in front right now?
Yeah.
No.
Okay.
Why can't we pull the 2 off right now? Because it doesn't go with the 100. Doesn't it only go with the x squared? So the first thing I have to do is split my problem apart. Why am I splitting it into an addition problem?
Because you multiply.
Because these are being multiplied. Now, can that come out in front? So I have the log of 100 plus 2 log x. Believe it or not, I'm not done yet. This can be simplified. Can anybody tell me how to simplify the log of 100? This is a review problem. Yeah, isn't 100 10 squared? And what's the base on this? What is the log base 10 of 10 squared? It's just 2, isn't it? When these two numbers match, it's just 2. So there's the completely simplified answer to the problem. What, Maya?
Then why can't we just leave that log 10 to the
Leave it here, you mean?
No, the one below.
Here?
Yeah.
Because that does simplify. For this, it's just like if you had the fraction 2/4, Maya. You could leave it 2/4, but the best way to leave it is 1/2. Reduce it. This reduces. This becomes just 2. So this is not wrong. It just isn't the best answer. This is the best answer. Okay, we have one more to do, guys, and then we're done. Okay, we're all paying attention for one more problem. Tell me, what do I do?
You are going to pull out the
Am I going to pull out the 3?
no, because it
Because it only goes with the E, so I can't pull it out yet. So what do I have to do?
plus E.
Exactly. ln 30 plus ln E cubed, Abby Brady. That's exactly right. Now, Julia, can I pull that exponent off in front?
Yeah.
Now, does anybody notice anything?
There's a number of you can simplify? Oh, there's an E on
What
that
does this
side.
mean? 3 times the log base C of E? Tell me about the log base C of E to the first power. What is that? That's 1 times 3. This is just 3. There's your best answer. Now you're saying to yourself, this is 4, and how do you expect me to remember that? I do. You are a 4th-year math student. We're going to practice and practice and practice, but you got to know your properties of logarithms. And you will after we practice. Today's day 1. A little confusing. Okay? All right. Let's pause here. Put your note sheets away. And who had a question about last night's homework? I heard a few of you say you actually did it. That's wonderful.
I did it.
I did it. After yesterday's debacle.
Yeah, they told me the teacher said something. We do. But we don't guarantee. Last side, this is my second time. But then they told me I wanted to protest this semester.
Did
My dad's like,
anyone find something that was just a little confusing or just downright impossible? Will.
so they won't, I won't have to do it again because like they already made up.
Come on now, Will. Do you know the property? When these two numbers match, that's the answer. No homework questions. We're all scholars.
Oh, that's good.
Karen? 34. Log x equals 4.
Wait, just one quick question. Where will you be next year?
Here.
Alright, I'll get my paper to you.
If I'm not in the room, just put it like log x equals 4. Okay? We're solving this equation. Now, what is missing here but understood? 10. Now we're going to rewrite that. And how are we going to rewrite it? 10 to the 4th equals x. 10 to the 4th equals x. So what's 10 to the 4th? 10,000. 10,000. So x equals 10,000. Anybody else? Okay, and here, I'm going to put a couple review problems up here. Let's see how we can do. So get out a sheet of paper if you would. You can use the same one you were using yesterday. Today I'm not going to put so many because I want to get them done.
Almost. Not really yet. This side, because you know on one side. She's gonna have to nose it into her brain. You can't give it any more brain damage than I already have. Suzanne, what was it over here? Yeah, she did.
Okay, I should hear nothing except pencils moving on paper. Okay. So we're gonna write down that first problem, and we're going to do it.
I'm giving you a word ball and a confetti. I made it on the. I had a Pomeranian. Oh. No, you have a pig dog. It's like a little rat.
Okay, girls, I shouldn't hear this chatting. I should hear you working on these problems. Come on, you two. You do them all. We're gonna stop in time to get them all covered.
Dude, I'm trying to follow yours. It's like, I don't know what it is.
Stop using that left. You still got that left.
She thinks it's so cute too. Like, I like fluffy dogs. I don't like my own hair. Square root? A third root.
Did you put number 1 on the board and show your work? Show your steps.
Katie's putting number 1 on the board. Is there anybody who feels like you had 2A satisfactorily completed? 2A? Will, right, you can put 2A up there.
Really,
Number 1, she's already doing.
What? 4 times 4.
I'm gonna need somebody to do 2B.
okay, I was, 1 was mine.
Oh, right, well, I didn't finish that. They were like, you're getting a doctor. Kaylee's getting a doctor.
I was taking my job, my own job.
Yeah.
Died like last year. She was higher. Yeah. She was from higher.
Are you texting?
If he has a passport, because my parents got him shipped over.
Michaela's getting a doctor.
Anytime you have your hands in your pockets, I'm just.
Yeah, okay.
Tyler, you got 2B?
Oh.
Sue's like my dog.
I really feel like high tech.
It jumps on everybody. What's your dog's name, Buddy? No, Sue doesn't like Buddy.
I hate it.
I've never heard anybody hate that
Would not leave me alone.
Brooke, you got 3B?
We just got our teeth cleaned.
Hey. 3B. Now, number 4 is today's lesson. Does anybody feel like you can do that page ribbon? There you go. Okay, then we're going to have them all up here and we're going to check them and talk about them. Okay? Bryce?
Okay, it wasn't
Ew, I hate that. Your mom really likes that. My mom likes that.
Okay. Let's talk about these. Thank you, those of you who came up and bravely attacked the problems. Thank you. Maya Brownlow, you told me you understood how to do this problem, right?
Yes.
So what's the first thing you did on your paper? Katie's got an outline, but I want to hear your voice. What's the first thing you did?
Well, the first thing you do is you plug in the one with the 0 and the -3, and you plug in the -3 for where the y is, and then you plug in the 0 for where the x is. And then I'm just going to exit out because you don't get it.
Now, this is the format of the equation. So when she's saying plug stuff in, this is what she's plugging it into. So she put -3 in for y and 0 in for x. That's gone, which just means a is -3. So then she has the equation that looks like this, because now she knows a is -3. Then what did you do, Maya?
Then I plugged in the next one, and I plugged in it for, I plugged the 1 in for x and
And that gave us this equation. It's kind of small. You may not all be able to see it, but it gave us this equation. So she divided both sides by -3 and said b equals 2/3. Then she just went over here and said, okay, b equals 2/3, so there's my answer. And we never ever multiply these two numbers together. They are separate. Does anybody have a question about that? There's a quiz in your future.
Just on the.
All this stuff. Okay, 2. This was yesterday's lesson. We did a great job. We understood, there's an understood 10 there. See how it's written? And then we translated. 10 to the -2 is x. What does 10 to the -2 mean? 1 over. Negative exponents mean 1 over. So we have 1 over 10 squared, 1 over 100. Anybody have a question about 2a? 2b, same thing. 4 to the 2nd equals x. That's easy. 4 to the 2nd equals x. X has to be 16. Remember, when we have equations like this, we translate them into their exponent form. 4 to the 2nd equals x. You've got to remember that pattern. 4 to the 2nd equals x. There you go, 16. (3a), beautifully done. All these are beautifully done. We got 100% up here. We're great. What's that negative exponent do?
Flip it.
Flip it. So I'm going to write it 4/3 squared. When I square a fraction, I square the top and the bottom, so that's 16 over 9, agreed? Good job. Uh-oh, another negative exponent. That means 1 over. What does 3/2 exponent mean?
Radical.
It means a radical. And what radical does it mean?
Square.
The square root of 16 cubed. What's the square root of 16? 4. Cubed is 64. 1 over 64. Beautiful. Remember, it had a negative exponent. That's why it's 1 over. And look at this. This is today's lesson.
Beautiful.
There's no middle step in there.
God.
Let me put the middle step in. You don't have to. If you get this, you don't have to put the middle step in. But the first step is break it apart as an addition. Then pull your exponent off. Very nicely done, Paige.